So what we'll start with today is Gurno duopoly with imperfect information. The players in this game are the two firms. Their actions are the two quantities that these two players will choose. The states will be L or H. So you know the Gurno game, we've played it a bunch of times, we've seen it a bunch of times earlier. The difference here is that as player 1, I don't know whether player 2 has a high cost of production or a low cost of production. What I know is the probability that the cost of production will be high versus low, but that's about it. I know that player 2 knows her own cost of production, and I know that player 2 knows my cost of production. For whatever reason. You could just assume that player 2 has better corporate spies than player 1. Now, in this game, there are two states of the world, L and H, and they correspond with player 2 having a low cost versus having a high cost of production. There are two signals. So each player will receive signals. For player 1, the signal received when the state of the world is H is the same as the signal received when the state of the world is L. What that means is that player 1 doesn't actually know what the state of the world is. Player 1 doesn't know whether player 2 has a high cost of production or a low cost of production. For player 2, the signal when the state of the world is H is different from the signal when the state of the world is L. So therefore, player 2 knows whether the state of the world will be H or L, depending upon the signal that is received. So player 1, because he doesn't know, has beliefs over what the state is. So player 1 thinks that player 2 has a low cost with probability theta, and player 1 thinks that player 2 has a high cost with probability 1 minus theta. Player 2, however, we don't need to define the beliefs for player 2 any more than this, because player 2 will know what the state of the world is. So based on the signal, player 2 will assign a probability of 1 to the state that the signal points to. The payoff function is basically profit, right? Player 1, player 2 of type 1, and player 2 of type 2, player 2 of type L, player 2 of type H, whether you want to call it 1, 2, or LH, it's up to you. Player 1 and both types of player 2 will choose quantities, and the payoff will be the profit function, will be based on the profit function. Player 1's profit will depend upon basically what player 2, player 1 is faced up against, because the quantities chosen by each type of player 2 will be different. So player 1's payoff in equilibrium will be a lottery, it'll be uncertain. However, player 2's payoff in equilibrium will be certain, right? Because player 2 knows what quantity she's choosing because she knows her own type, and she knows what quantity player 1 will choose in equilibrium. So for player 2, it's a certain thing. Okay, so what we'll do next is, it's actually a question in your book. It's exercise 287.1 from the text. Let's see if you can see this. 287.1 from the text. And we're just going to solve that on the board next. All right, see you.